This tutorial video covers the V500 triggering system for a 4-cylinder engine with 36-1 crankshaft triggering and no camshaft sensor. You can see up here the missing tooth waveform. This is the waveform that comes out of the sensor. If you used an oscilloscope, you would see this waveform. You can see here the missing tooth. The dashed lines indicate where the missing tooth would have been, and obviously when the tooth is not there, the waveform flattens out in the gap between the actual teeth that are there. The trigger events represent each cylinder event that happens. Now on a 4-cylinder there are 2 trigger events per engine revolution. These trigger events can be moved forwards and backwards in relation to the sync pulse by changing the ref sync offset. In this case, the ref sync offset is set to 1. If you increase the ref sync offset, the trigger event moves to the right. It moves 1 tooth to the right for each increase in ref sync offset value. It moves to the left for each decrease in ref sync offset value. The ref sync skip refers to the number of teeth between trigger events. In this case, there are 17 teeth between this trigger event here and this trigger event here. So the ref sync offset has to be set to 17. As a note, the ECU measures a triggering event as the waveform crosses 0 volts, and you can see up here that's what this diagram shows, and you'll see the triggering event occurs just where the waveform crosses 0 volts, so in the middle of the reluctor waveform. Down here you can see the trigger events as the ECU sees it, and the ignition and injection output events. We will use this to represent what the ECU sees the triggering as being. It's a falling edge trigger, so the actual trigger event occurs on the falling edge. These 2 lines here are ignition outputs. You'll see that with the ignition offset of this output set to 1, the first ignition event occurs directly after this triggering event here. With the ignition offset set to 0, as in this ignition output here, the ignition event occurs here. The reason for that is the combination of the missing tooth and a triggering event reset the ECU counter. This means that the next triggering event is the 0 point. So where you have an ignition output, such as this one, and you have the ignition offset set to 0, this will output a pulse directly after the trigger event that follows both a sync missing tooth event and a trigger event. The same applies to the injector outputs. Here we have an injector output with an offset of 1, and here we have an injector output with an offset of 0. You'll also note that the injector output goes low, that is, turns the injector on at the triggering event. This occurs always with the V500 ECU. I hope this tutorial's been informative, and I hope you look forward to future tutorials on triggering and various other aspects of the V500.